Welcome to Geometry Lesson 12.2. We're going to take the information we learned from 12.1 and use it to solve right triangles. In Lesson 12.1 we learned that trig can be used to solve 30 degree, 45 degree, and 60 degree angles, but it can also be used to solve angles with other degrees. In the 1500s, a mathematician named George Rheticus was the first to relate trig to the sides of a right triangle. He spent 12 years creating tables listing decimal approximations of trig ratios. He worked all of these ratios out by hand. The tables saved mathematicians, astronomers, surveyors, and navigators a great deal of time in their daily work. We'll actually be going over some of these tables and learning how to use them in class. Before you had wonderful calculators like you have now that do these problems quickly, you would use the tables to do your math. So let's look at example 1. We have a triangle that's obviously going to be a 30, 60, 90 degree triangle. So that's the first thing you need to recognize. Look at your image, check out your figure, and recognize what it is. Redraw it if necessary. If you like your right angle down on the bottom of the triangle with the 30 degrees vertical, go ahead and do that. It will still work. So we recognize that the 30 degrees as an angle in a 30, 60, 90 creates the ratio 1 to 3, square root of 3 to 2. So let's go ahead and draw those in there on the triangle, and the square root of 3 will be your long side, 1 is your short leg, and your hypotenuse will be the short leg times 2. So there we have our ratios. And we can use these ratios to solve angles. One of the things we can say right away is we know that the cosine of 30 degrees, cosine, if you remember, SOHCAHTOA, cosine is adjacent over hypotenuse. So here's our 30 degree angle. We have adjacent, which is square root of 3, over the hypotenuse, which is 2. So now we have our trig ratio for one of these angles. We could go ahead and do all of the ratios that we need to in this triangle. Let's look at another part of this same example, and be sure to use your calculator. Be sure your calculator is set to degree mode. So that means when you look at your calculator on the bar that gives you your answers, it should say degree, DEG, up in the top there. If it doesn't, you need to change your mode. And if you don't know how to do that right away, I know on my calculator, next to the second button, if I push second DRG, that takes me to radians. If I push second DRG again, it takes me to gradients. If I push second DRG again, I'm back at degree. And it's very easy to push those buttons in error, so always check that you're at degree when you begin these problems. So we're going to solve for tan 72 degrees. Our goal is to find what the decimal approximation is for tan 72. So in my calculator, I input 72 degrees and then push the tan button. And my answer is 3.077768, and we round that off to 4 places, and instead of the 6 we'll have the 7 there. For C, they're asking us to find the decimal equivalent of sine 26.2. Yes, you can have decimals in what you're trying to find also, but you'll work it the same way. Simply input 26.2 into your calculator and push the sine button. Mine says it's approximately 0.4415058. I round that off and it's 0.4415. If you have any difficulty with doing these two problems, be sure to contact me so we can get the steps written out for your calculator. So when we actually go to solve a right triangle, that means that we're finding all the other angle measures not given and the side lengths that were not given. So if you have information given, you'll use that to solve for everything you don't know. We'll use a variety of trig ratios, the p-theorem, and the sum of the angles of a triangle postulate to solve right triangles. So let's try some. Example 2. We're going to solve right triangle ABC. Right now, what do we know? Well, it's a 90-degree triangle, and we have an angle of 72 degrees. So the easiest, simplest thing we can state right now is the measure of angle A. And the measure of angle A is going to be the missing measure of your triangle. Now in the past we've used 180 degrees and then subtracted to solve, but there's actually a shorter method. We know in a right triangle that we already have a 90-degree angle here. So angle A and angle B are complementary. They add to 90 degrees. So that means all that you have to do is solve by taking your known angle 72 degrees and subtracting it from 90. So angle A will equal 90 minus 72, which is 18. And let me fill that in here. And we have 18 degrees. So now that we have that 18 degrees, we can move on. We have two side lengths we need to solve. We have B and we have C. We have all of our three angles, and then we'll solve for all of our three sides. So to solve for B, we're going to use trig ratios. There's several different ways to do this, but we'll start with what the book suggests. And you can see that B is opposite 72 degrees. And you have values for, if you look at the 72 degrees, we're going to solve for opposite, and we have adjacent. So we can use opposite over adjacent as a ratio, and opposite over adjacent, think of SOHCAHTOA, is tan. Tan is opposite over adjacent. So let's solve for tan 72 degrees, which is opposite over adjacent. The opposite is B, which is what we're eventually solving for, and the adjacent is 8 centimeters. Now let's take this ratio, and right now what I'm going to do is remove this one to just make it look simpler. And I'm going to multiply both sides by 8 centimeters to get to B equals. So when you have something like a tan 72 and you multiply it by a number, you put the number in the front. No, you don't have to, but this makes it much easier. So in the beginning, trust me and do this. If you decide that you're going to put it in the back later, that's fine, but be sure you don't put it next to the 2, because you may think you're doing tan 728. So B will equal 8 times tan 72, and in your calculator what you do is input 72, push the button for tan, you'll have an answer. Push the button for multiply and the button for 8, and you will end up with, and your result for 10 would have been 3.0777. That's to keep you on track. And this times 8 will be approximately 24.6 centimeters. Now, unless they state otherwise, when you're solving for a decimal, that's an actual length of a side. I'll say that again. When you're solving for a decimal, that's an actual length of a side, it should be solved to the tenths. When we're using our trig ratios, as in example 1, and we're just solving for the decimal of a degree, you go out 4 spaces. So I know this is going to be confusing, but remember, this would be something that you would be using. Example 2 would be something you'd be using to actually measure a length. You don't want to go out to 4 spaces to measure a length. So now we have that 24.6, we have our 18 degrees. All we need to do is solve for C. And to solve for C, we'll use trig ratios. C is the hypotenuse of the triangle. So we're going to find a ratio that we can use that uses the hypotenuse. And if you take the 72 degrees again, you'll see that you have adjacent, the 8 centimeters, over the hypotenuse that you need to solve, and you can use that ratio. Well, for angle B, or 72 degrees, adjacent over hypotenuse would be cosine. That comes from SOHCAHTOA, so CAH, adjacent over hypotenuse. So let's go ahead and put that in our ratios. Cosine 72 is adjacent over hypotenuse, which would be 8 centimeters over side C. I'm just restating it in this part of the equation. So right here in this part of the equation, all I've done is just remove the A over H to make it look like something workable. And what do we need to do to begin to solve this? Well, we need to undo our fraction. So let's multiply both sides by C. And when we multiply by C, or by any number that's in this denominator, you want the number to go to the left of the cosine 72. So C times cosine 72 equals 8 centimeters times C, divided by C times C. So we've multiplied both sides. And what will happen is these C's right here will cross each other out, and we end up with the equation C times cosine 72 equals 8. If you're already confused, I want you to go back just a little bit to this first step and write it down on a piece of paper, but write it vertically. I haven't done that on this slide because it won't fit. But write it vertically, each step, and then write the steps on the side. So the first step would be to state your ratio. The second step would be to write the equation. The third step would be to multiply by C on both sides. And then the fourth step would be to restate the equation again. Now that you have this part of the equation, we need to solve for C, and C is being multiplied by cosine 72. As in any algebra problem, you can divide or multiply the items that you need to remove from what you're solving for. In this case, we have a full value here. Cosine 72 is one value. So we will divide both sides by cosine 72. And this will leave us C equals 8 centimeters divided by cosine 72. Now, how do you do that? Well, I've given you the answer here, so you can find it on your calculator. But on my calculator, I actually take 8, and I'm able to divide by 72 cosine. You may have to possibly do 72 cosine and multiply by 8, but there's actually another way. There's a way to use the invert button on your calculator. If you already know how to use it, go ahead and use it. If not, we'll be learning it in class. But once again, I'll state that in my calculator, I could take the 8 and divide it by 72 cosine. So 8, I enter 8, divided by, and then 72, and then push the cosine button. I end up with approximately 25.8885, and because this is the length of a side of a triangle, we will and I just realized that the book didn't hold true in what they're doing, so I'll do it right now. Our answer should be 25.9 centimeters. So your homework for 12.2a is numbers 1 through 12. Number 1 through 3, just use your calculator to find the decimal, like in example 1. Numbers 4 through 6, you already have your decimal answer, so you're going to convert to degrees. You'll use the inverse on your calculator. So as an example with number 4, you'll enter 9.2151. You push the second button and then the tan button. Your answer should be 83.8066 degrees. Round that to 83.8. For number 7, we're actually 7 through 9, we're actually solving one triangle and we're solving all the pieces. And if you happen to have an answer key, I'm going to tell you right now, don't use it. The answer key all of a sudden jumps into another way to do this problem after they gave us a perfectly good example in example number 2. So use what we learned in example number 2. And the first thing we can see for number 7 is that we have our 90-degree angle, a 17-degree angle, and we need to solve for angle E. So angle E would be 90 minus 17, which equals 73 degrees. And that happens to be the answer to number 9. So we're going to use the 73 degrees. Let me write that in there. To solve for x. And with x, to solve for that side, if we look at our 73-degree angle, we see that x is opposite and that we have a hypotenuse. Opposite over hypotenuse is sine. So use sine 73 and it equals opposite over hypotenuse, which is x over 20 meters. And let's undo our fraction by multiplying both sides by 20. And that will give you 20 times sine 73 equals x. And go ahead and perform this on your calculator. In my calculator, I push 73, then sine, and then I do multiply by 20. The approximate answer is 19.1260, which would be 19.1 meters. And here are the hints for the rest of your problems. For number 8, use sine 17. For number 10 to solve, use the P theorem. For numbers 11 and 12, you're going to use tan G and tan H, and you'll solve them like we just did in example 2 by using the second tan, which is actually the inverse tan button. So if you have trouble with those, be sure to contact me, and we'll be moving on to 12.2b shortly, and we'll talk to you soon.